every now and then a ship comes along that changes the world. The Queen Mary was built all the way back in the 1930s, but she had a career and a record roll longer than the list of streaming services you've forgotten you're subscribed to. From peace to war, and back to peace again. The Queen Mary did it all until the jet age finally caught up to her and put her out of a job. Fortunately, this grand old lady is still around. I even got to visit last year. But despite all the success and the glitz and the glamour, there are a few behavioural quirks that stemmed from her design, some which have become legend. I wanted to figure out exactly what was going on beneath the hood, so I sat down for a chat with Stephen Payne. Stephen is a brilliant designer and engineer who's worked on so many ships I suspect he actually might secretly be designing them in his sleep. The Destiny-class cruise ships, the Rotterdam 6, you name it, but his real pet project was the Queen Mary 2. Ever heard of it? So if anybody's well placed to teach us about the original Queen Mary's design, it's him. Ladies and gentlemen, I'm your friend Mike Brady from Oceanliner Designs, and this is an inside look at some of the Queen Mary's design quirks.
I want to start by prefacing comments by saying there's no such thing as a perfect ship. The reason being that a ship is a commercial enterprise there basically to make money and to pay back the investment as well as the running cost of operating the ship. And so there's always going to be a conflict between what the ship is going to offer her passengers to what she has to do on the commercial side. And the trick is to try and align those things as far as possible so that basically the passengers are happy and the shareholders of the owning company are happy. Now, the original Queen Mary, as we've said, her design started in the late 1920s. And at that time, Cunard had three disparate, completely different ships operating their express passenger ship service. There was the Mauritania from 1907. At the time was still the fastest merchant ship in the world. She used to cross the Atlantic around 26.5 knots at that period. Then you've got the Aquitania, which was somewhat larger, half as big again as the Mauritania, but slower. She was Cunard's answer to the White Star's Olympic class. And then there was the Berengaria, which was originally the Imperator of Hamburg America line. And she was ceded to Cunard for the loss of the Lusitania. So these three ships were quite different, operated at different speeds. They enabled Cunard to operate a weekly transatlantic service. So one ship would depart every week on the Atlantic. And what we also have to remember is that these ships would also stay in port for several days between voyages. It's not like today, where the ships are in at 7 o'clock in the morning and sail at 4 or 5 in the afternoon. In those days, the ships were in port several days. And to give you an example of why that was necessary, the first two queens, Queen Mary and Queen Elizabeth, didn't have a laundry. So all the laundry had to be assembled and taken off the ship, and a second set would be brought on that had come from a shoreside laundry.
I can tell you that till recently I had probably more laundry backed up than probably came off Queen Mary in between trips. I've just caught up. But we're talking like 20,000 napkins and things like that. Like
all the napkins, tablecloths, all the bedding, absolutely gargantuan amount of stuff that would need washing. So yeah, phenomenal thing to do, plus all the storing. And of course the ships used a prodigious amount of fuel. So over 1,000 tons of fuel a day, the first two Queens, and you couldn't pump that on board quickly. That would take a day or so to fuel up, and they also had to take fresh water on board as well. So it was a huge process. Let's look at some of the features of this first Queen Mary.
Great.
And you notice one of the things is the well deck forward. And to be honest, I don't know why they introduced that well deck, because what it tended to do in rough weather, water would come over the bow of the ship and would fall into that well deck and would literally destabilize the ship, because it would be several hundred tons of water. Okay, it would rapidly disperse overboard from each side, but for that short period where the water was there, it was a huge destabilizing effect. And it must be said, Queen Mary was a very, very poor ship in terms of stability. When the ship was first built, Cunard felt that it would be so big that they didn't need to put handrails in the corridors, passenger corridors. They felt it would be so stable. But on an early transatlantic voyage, it was so rough that dozens of people suffered injury, and they had to have a fleet of ambulances waiting when the ship arrived in port. And so they rapidly retrofitted the fitting of handrails. And it wasn't until 1958 that stabilizers were fitted to the Queen Mary. And originally they weren't going to bother, because they assumed that the ship in the late 50s wouldn't last that much longer. They had started plans for the next ship, which would have been Q3, the abortive transatlantic liner. And so they didn't initially think that it was worthwhile fitting stabilizers to the Mary. But when plans for Q3 ran into difficulty, basically because the aeroplane was taking more and more business, and Cunard realised they needed a dual-purpose ship rather than just a straight transatlantic ship. But they decided to retrofit Queen Mary with stabilisers, because they knew that she would be in service for longer than they originally anticipated.
They got a good few extra years out of her. This is going to be one of those recurring themes, is that at the risk of making assumptions when we don't have her design team and the Cunard executives to talk to about this, it seems that, first of all, you can tell they learned their lesson, because they didn't repeat this on the Queen Elizabeth, but we'll talk about that later. But second of all, this is just one of those things where it seems like, why did you include a well deck? Because that's kind of how we've always done it.
No, that's right.
This is just such an archaic feature to appear in an ocean liner in the 30s.
And in fact, you see Queen Mary wasn't the only ship. I've seen pictures of like Normandy in a rough sea, and she's almost at 45 degrees. It's incredible. When we test the stabilizers, the most I've ever got up to is about 20 degrees. And that is frightening. And we always get telephone calls from the galley to say, please stop, because everything is falling off the stoves and the crockery and everything like that. So I can't imagine what it would have been like at about 45 degrees.
Yeah, and there's that famous story where she took that monster wave, and I think the inclinometer registered something in excess of 50 degrees.
And in fact, one of her passengers was the author Paul Gallico, and he was so traumatized by being on the ship in a bad storm that he wrote Poseidon Adventure,
which is eventually filmed aboard
Queen Mary.
It's such a great loop for that story.
Absolutely. So what a sort of strange turn of events that is.
So I mean, I know they tested this hull extensively in tanks, which is interesting. They did so much tank testing with models. Why do you think they didn't pick up on these kind of behavioural quirks before she went to sea?
I would imagine that the model testing in those days was much more primitive, because when we do it now, we have a untethered, it's a free sailing model,
Right.
with sensors inside the model. So I don't think they would have had that in Queen Mary's day. I think it would have been tethered, and certainly the instrumentation on that wouldn't have been the small electronics that we have today, measuring all the different parameters. But the other thing is the center of gravity. The stabilization, I think, must have been that she had a higher center of gravity than what were they originally envisaged, because that is what causes the roll, is having a high center of gravity.
Can you explain just briefly? I know that there's a balance that passenger ships have to strike, where you can have a long, slow roll or a quick, snappy one. What kind of goes into designing the ship to achieve maximum passenger comfort?
The big parameter that you've got to play with that affects the rolling is the beam of the ship, the width. And of course, the wider you go, the more expensive the ship's going to be. And in fact, although it's not noticeable, even Queen Mary 2, she's 41 metres on the waterline, but on the boat deck, she's only 40. So we have half a metre of tumble home between the waterline and the boat deck.
Right.
And that's purely there to save weight and cost. The yard said to me, or the ship as I designed it had 40 metres, and they said to me we would be more comfortable having the extra stability by going to 41. And ultimately they were responsible by contract to provide the stability and the speed and everything. So I was only too happy to agree. When you've got a wide ship and you've got what we call a high GM, which is the margin of stability from the center of gravity to the pivot point, which is very important, GM. If it's too high, you get a very snappy, as you said, the ship comes back like a rocket and can be very uncomfortable as well as dangerous if it's excessive. Or you have a very low, gentle roll that people don't tend to feel so much. So it's and it depends, of course, how you load the ship as well, because as you use fuel, you've got to replace that fuel that's low down in the ship, because that provides a stabilizing effect. So let's look at the forward funnel area. So first off, you see that the funnel is not self-supporting. It's held in place by all those guy wires, and of course they obstruct the deck. One other interesting thing, and you can just see it on your plan there, Mike, it says the rake of the funnel is 1 7/8 inches per foot.
Yep.
Go to the second funnel, it's 1 15/16 inches per foot. And the stern funnel, or our funnel, is 2 inches per foot. So when you look at the ship, you may think that the three funnels have the same rake, the same angle, but in fact they don't. They're all at different angles, but it was designed specifically to give the most aesthetic and pleasing effect when you look at it. Now, the other thing, grouped around each funnel, these huge intakes, vents, and we call these cowls, COWLS, and they were the intakes for the air going down to the boiler rooms. The smaller ones would have been bringing air into the accommodation. But you see along the length of the ship, there's a proliferation of these vents. And okay, they look very pretty. You look at, you compare or look at Mauritania, and she had a veritable forest of cows along her length. But what you've got to imagine is that from each one of those cows, port and starboard, you've got a great big trunk going down throughout the ship. And so this is taking up space within all the accommodation areas, making the arrangement of the decks that much more difficult. And it also presents an enormous maintenance problem, because these are ducts manufactured from steel. Okay, they'll be painted, but in the salt-laden air that's being drawn down into the boiler, it's a tremendously corrosive environment. And so it would have been a constant battle against corrosion to keep all these trunks in good condition.
You can actually see it here. So this is the, I think the boat deck, or the promenade, the upper promenade deck, the sun deck, where there's essentially vents every, 20, 30 feet. Probably not so much a problem on this deck because it's open decking, but then of course when you get below here, you've got...
Well, you've got the public room decks, and then below that you've got the cabin decks. So you've got to squeeze in the arrangement of the cabins to avoid, interfering with all those vents. So you would place the vents first and the staircases, and then you would do the arrangement of the cabins.
And that naturally was something that designers had to do anyway, because you've got, of course, 3 functioning funnels. So you've already got your boiler uptakes going straight through the middle.
You've got another big uptake for the engine hatch, which was there to lift out parts of the machinery in case you needed to. We don't do that today. We enclose everything, and if we need to take stuff out of the ship, we cut a hole in the side of the ship. And in fact, the Statendam, the first Holland America ship we were building, a few months before her delivery, one of the inboard diesel engines self-destructed, suddenly oversped and broke up, throwing bits of metal everywhere. And we had to dismantle the garbage room on the deck above, take out the deck. Then we had to cut a hole in the side of the ship, remove the good engine that was the outboard one, dismantle and scrap the inboard engine, bring a new one in, replace the outboard one, replace the deck, and then all the garbage equipment.
Big job. Big job.
Big job. Absolutely. Absolutely. So, could we just go back to that deck, Mike? Just one more thing to point out are the expansion joints. And you can see on the deck there, along the length, there's an expansion joint. And what this is a cut across the deck, an opening that would be covered with a rubber gasket with a sliding, usually a brass plate on top. And as the ship flexed in the waves, rather than having cracks forming through overstressing in the superstructure, the ship would actually move apart and create a gap, which the rubber gasket would fill. And then as the gap closed, the rubber gasket and the brass plate would move backwards and forwards across the deck. And you see these early ships have these expansion joints all along the length of the ship. And of course, Titanic had expansion joints. The Elizabeth did, but QE2 didn't. And she also had an aluminium superstructure, whereas these early queens were all steel. And QE2 suffered horrendous structural problems right from the word go, with cracks forming. And By that time, it was assumed that the knowledge of structures was sufficient, that they knew what they were doing, but clearly there were still things to be learned. And of course, computers were still very much in their infancy. Whereas today, we use very complex computer modeling to work out the strengths, and we can add structure where we know places are going to be overstressed. That's why Queen Mary 2 doesn't have any expansion joints.
It's interesting, the design ethos of Queen Mary by the time she comes around, that designers have now well and truly moved away from boats actually on chocks on the deck. We've now got gravity davits, which are obviously a huge step forward in, safety at sea. And in fact, they're not too dissimilar to what you'd find on ships like Queen Mary 2 today, no?
The davits themselves are a much better arrangement.
Yeah.
Gravity davits. So they come down, brought down to the deck by gravity, obviously under control with a winch, and then allowed to go down to the waterline.
One of the things that's apparent when you visit the Queen Mary, I have to say, I was a little bit underwhelmed by the size when I went to see her. And it's probably because I've been spoiled by having got to be on Queen Mary 2, because you have a hull and then superstructure about as tall as the hull on Queen Mary 2. Whereas Queen Mary, she's very much in the style of the transatlantic Greyhounds, where she's got a very long, essentially thin hull and a tiny superstructure on top.
We measure passenger ships by gross tonnage, which confuses a lot of people because it's nothing to do with weight. It's a volumetric measurement, and it originates from putting beer barrels inside the holds of ships. And a beer barrel, in old terminology, was called a tunny, and that's where we get the word ton. And up until fairly recently, it was 1 ton was 100 cubic feet of space inside the ship, earning capacity. You had to measure every space and do the calculation. So because it was open a lot to interpretation, it's now been standardized to a formula where you use lengths and breadths and various things. And it gives, obviously, not exactly the same figure as it would have done if you'd have measured it, but it is a rough indication, and that's what we use now to determine the size of ship. So the original Queen Mary was 81,000 gross tons. Titanic was 45,000 gross tons, so she's almost twice the size of the Titanic. But Queen Mary 2 is 150,000 gross tons.
One of my favourite Queen Mary 2 facts is that she and Queen Mary share, I think, it's a very similar displacement of around about 80,000 tons, which is weight of ship sitting in the water, right? How much water it displaces.
It's the weight of the ship when you put it on your bathroom scales.
This is a great demonstration of this fact, of this information that you're saying, because although Queen Mary and Queen Mary 2 essentially weigh a similar amount, Queen Mary's gross registered tonnage is essentially half that of Queen Mary 2. So you've just got more space inside of this hull, more ship, but it weighs the same. Because of course, Queen Mary, you've got this unbelievably comprehensive steam plant running probably 3/4 of the hull essentially below the water.
That's right.
Which with Queen Mary 2, you don't need to worry about so much.
No, and on the weight front, the first Queen Mary is fully riveted, so you've got overlapping steel plates with I think 13 million rivets on board the ship, and that's all added weight. Nowadays we weld the plates together, and not only is that vastly superior strength wise, and there have been some tests done, and I think it's over 40% better for strength than being riveted. But you're not carrying around all this extra weight. The first Queen Mary, and we're going to talk about that as well, she had 27 boilers. She had 24 standard boilers for the propulsion plant, and she had 3 auxiliary boilers. So that's why she needed the 3 funnels in order to vent from those 27 boilers. When comparing her to the next ship, the Queen Elizabeth only had 12 boilers. So that enabled them to reduce the number of funnels down to 2. So immediately you've lost the funnel trunk right through the ship, plus all the extra air intakes, those ducts are going to be much reduced. But the Queen Elizabeth's 12 boilers, because they were that much bigger, actually had much less surface area. Normandy introduced air conditioning on the transatlantic run. Queen Mary took it a stage further, and in fact, when she was built, she had the largest air conditioning plant on a passenger ship. And the first class dining room, the first class lounge, and the tourist dining room, which was basically second class at the time, was air conditioned. So that is where air is taken from the outside, it's dried, a certain amount of moisture is added, and it's either cooled or heated. That's what we call air conditioning. The rest of the ship took the outside air and either heated it or cooled it. So there was much less conditioning done. So it was basically just ventilation. And that wasn't so bad on the Atlantic, but in summer, and especially what made life difficult when the ship went cruising, as Queen Mary did in the early 1960s, in the hot climes, it made life on board quite unbearable.
Queen Mary was taken off the Southeast Asia theatre during the Second World War and sent pretty hastily back to the Atlantic. Obviously, it tied in pretty well with taking American troops out over to Britain, but I know that it was absolutely miserable when you had 6,000 men crammed into this thing. She was operating in Sydney in summer, which is, 40 degrees Celsius, 90% humidity. Nightmare.
Well, when you think on the Atlantic, she had over 15,000 troops on board.
Obviously something she was never really designed to do.
2,500 was the normal passenger complement. Another interesting thing here, if you go a little bit aft, Mike, to the veranda restaurant area, you see here the veranda restaurant behind the last lifeboat there, and you see it's a single deck height there. That was the veranda restaurant. But in her second year of service, on top of that was placed a new deck house for the engineers. And the reason was that the accommodation inside the ship was so cramped for the crew that the engineers revolted, and they had to build a new section of accommodation on top there for the engineers. Yeah, I think there was a lot of complaints, and certainly it must have been effective, because Cunard, built that extra deck house on top, which, must have been expensive to do.
They did pretty well, because essentially they got some of the best real estate on the ship. They got their own apartment block, really.
Yeah, absolutely. Queen Mary was the only ship of state of the 1930s, so of Europa, Bremen, Normandy, Rex, Conti de Savoia, she was the only one that turned a profit without a government subsidy. All the other ships needed a government subsidy. Queen Mary always carried more passengers, because Normandy, fabulous ship. Absolutely, she costs twice as much to build as Queen Mary, and in fact they're the same size. But first class was extremely lavish. But the other two classes were okay, but Queen Mary's second and third class, or tourist and third, what they called it, provided much more for passengers, and passengers tended to gravitate in those classes to the Mary. And in fact, a lot of people said they felt uncomfortable on Normandy, even in first class, because it was just too lavish.
Queen Mary's design, I remember reading that her interior design was kind of panned by a lot of critics when she was introduced, because it was just so eclectic and hodgepodge, but it seemed to work really well.
Yeah, the architectural press slammed the design choices and the decorative features around the ship when she was built. But, Queen Elizabeth didn't have that issue, but QE2 certainly did. That caused a lot of controversy, and so did Queen Mary too. There were people who didn't like that at all, said it was too old-fashioned and everything. We were firmly in the mould to produce something that would have echoes of the first Queen Mary, and that's why the name Queen Mary 2 was chosen. While we're there, Mike, there's the second funnel there that has a single whistle. The forward funnel has two, but that one has a single whistle, the middle funnel. And they were made in Sweden by a company called Typhon in the early 1930s for the Queen Mary. And we have that middle whistle on board Queen Mary 2. It's the starboard whistle on the ship. We had it reconditioned by Cockham's, and we had a replica made, and we converted them from steam into air. So we had the voice of the original Queen Mary. I mandated that there's a steam line up to those two whistles that originally blew steam out to make it look as though the whistles were being operated by steam. Unfortunately, that doesn't seem to be working.
Anyone who's been up there when they're testing those whistles can attest to the ground shaking power of those old Typhons. It's that beautiful deep tone.
10 miles is the audibility. The design of Queen Mary and the Queen Elizabeth, they were the smallest ships that could operate a weekly transatlantic service. So speed had to go up to 28.5 knots. They had to, 1,000 tons of fuel a day. So they had to carry enough for the 3-4 day crossing that they would be operating on. 2-3 day turnaround, and then back. And the two ships were able to operate that weekly service that previously 3 ships had operated on. Structurally, when you go on the old Queen Mary, a tremendous amount of the internal structure has been removed, and there have been concerns whether or not she's about to sort of implode in herself, but surveys have shown that what remains is still okay, but she wouldn't be able to go to sea again. Definitely not. And the other big problem are all those rules and regulations that we've spoken about. One of the reasons that Queen Elizabeth was pulled out of service in 1968 rather than going on to 75, which was the original plan after the big refit that they did in 65, where they added full air conditioning, added an outdoor swimming pool, added, I think there were 250 extra cabins that they put private facilities. So they did huge reef. 4 months it took in 1965, and she only sailed to 68. Part of the problem was that all the extra regulations that were needed to comply, that the Americans mandated after a fire on the a small cruise ship, the Yarmouth Castle, and Cunard didn't think it was possible to do that. And with Queen Mary as well, as a hotel, some of the staircases are enclosed, so they're not fully open as they would have been when the ship was in service. You used to go on the old Queens because you had to, because as you know, John Maxstone Graham, the celebrated maritime author who's sadly passed away, the only way to cross. You're going on those ships like you would a train or a bus. It's a means of getting A to B. You don't have to go on Queen Mary 2 to get to the States. You can fly. Do it in 7-8 hours. So if you do elect to go on Queen Mary 2, you expect to be entertained and to be able to do various things. It's all part of the attraction.
But Stephen, it's been absolutely fantastic having you on.
And thank you to everybody who's been listening and will listen in the future. No, it's been great chatting away.
Until next time, my friend.
Good night, all. Soon.
Everybody, thank you so much for watching us. It's been wonderful to spend the evening with you. As always, stay safe and stay happy, and we will see you again next time.